Okay, so the range we said here would be 2, 3, 4, 5. Now you notice I have more numbers in my range than my domain. Is this a function? No, why not? Right, because this 3 is repeating. In fact, 3 is really a two-timer, isn't it? 3 is going out with 4, 3 is also going out with 5. Can't happen, right? X cannot be a cheater. So this would be an example of not a function, and the problem with that is the 3 is repeating. So if you have more elements in your range than you do in your domain, that's going to be a problem. Because if I ask the question, what is 3? And you tell me 4 and 5, well, which one is it? I can't decide. I cannot use bias, right? Okay, let's look at this one. First, let's start with the domain. Domain would be, and let's go in numerical order. So starting with the smallest number. What's the smallest x value? -2, then -1, 1, and 4. Good. What's the range? 2, oops, let's go in order. 0. So I'm just putting the small one first. 2 and 7. Would this be an example of a function? And you might think it's a no, but it is in fact a function. It's a function because it doesn't matter if the answer y is always the same. It's a little sexist in that way. X cannot cheat, but y can actually do whatever y wants. Okay? So the fact that you have a smaller group of range, you have at least every single question has a unique answer. That would be like, when you know who you can ask, which parent you can ask and get a yes, and which parent you can ask and get a no. So it doesn't matter if you ask your dad always the same question, his answer is always yes, right? Or you could ask him you could ask him any question you want, different questions, the answer is always the same. That's functional, right? If you ask your mom different questions, doesn't matter what the question is, and she always says no, then that's functional, right? Because as long as we don't change our mind or give two answers that are actually opposites. So yes, it's a function. Okay? Each question has an answer. Doesn't matter if that answer repeats. On to the next page. For a function defined by y equals f of x. If the point is -2, 5 is on the graph, then f of -2, because that's the x value, f of x equals y, the y value equals 5. So the function value at -2 is 5, or f of -2 is equal to 5, okay? So here, if I see f of 4 equals 7, what ordered pair are we talking about here? 4, 7. Okay, 4, because we're saying f of x equals 2y. All right, let f of x be this linear equation, right? 2x minus 5. Now, normally you're used to, this is the same thing as y equals 2x minus 5. Okay, you're used to seeing that from Math 60 as a linear equation. The only difference here is that the nice thing about function notation, it allows us to retain the x value and see what number was plugged in. Because normally you put in 3 and then you do all the math and you get whatever y is. Here, when I have f of x, I'm just going to replace whatever is in for x with the 3, because f of 3 minus 5, I get 6 minus 5 equals 1. So that ordered pair is 3, 1. Okay? F of 0. If we find f of 0, we're going to replace the 2 with a 0. Sorry, with the x with a 0. And then we're going to evaluate. Evaluate means that I'm in finding it. I'm not solving. I'm just plugging a number in to get the y value. What would the y value be here? -5. Good. Evaluate f at -1? That's the same thing. F at -1 is still f of -1. What's the function value? The function value is going to be the y value. So we're going to plug that in for x, and then we're going to simplify. So we get -2 minus 5, which equals -7. Now, notice that word evaluate. Evaluate means we know x, we're trying to find y. We're plugging it in. How is that different than this right here? Notice the difference. Solve. F of x equals 9. What does that mean? Yeah, we're trying, we don't know x, but we know that y is equal to 9. So how would I set this up to solve? What would I do? Oh, it's just a sentence, a statement, okay? So we would go 9 equals 2x minus 5 because we want to actually solve for x. See how we have the word solve? So the only time we're solving is when we don't know x. What am I going to need to do in order to solve for x? Yeah? So I have 14 equals 2x. Divide by 2, divide by 2, I get x equals 7. So that means f of 7 equals 9, or since we solved it, we could put it in set notation. If I just write f of x equals 9, and I want to know what the x value is, this is right here, the set notation, which means that the solution that we solved for, we got 7. Do you see the difference between